So now we have to implement this function f equal to ab plus c using 8:1 mux and tabular form. So the first 4:1 mux is done, and now we are implementing it. This is done. Yeah, this 4:1 mux is done, and now we are using it 8:1 mux. For 8:1 mux, what we see actually for 8:1, we should use three select lines, and we have only function with the three variables. It means our all variables will go at the select lines. So A, B, C, all will be used at select lines. Now, if we use the all A, B, C at the select lines, then first of all, we have to write all the possible combinations of A, B, C here. Then A complement, B complement, C complement, A complement, B complement, C, A complement, B, C complement, A complement, BC, and so similarly A, B complement, C complement, A, B complement, C, A, B, C complement, and A, B, C. So these are the all possible combinations of select lines we have to put in. Now the point is how to select the index values actually. So this is your 0, this is 1, 2, 3, 4, 5, 6, and 7. There is no other row present here. Only one row is available from 0 to 7. All the combinations are covered. Now our function is, now look at the function. Our function has min terms 1, 3, 5, 6, and 7. Only one row is available. So first of all, we have to encircle it. So 1 is present here, encircle it. 3 is present, encircle it. 5, 6, and 7. So whatever is encircled will provide you. First of all, we have to write here I0, I1, I2, I3, I4, I5, I6, I7. This column is not encircled, so it will 0, it will be 1, it will be 0, it is encircled means 1, not encircled means 0, encircled means 1, encircled means 1, encircled means 1. Now we have to draw this 8:1 mux. Now we will draw the 8:1 mux. So this is the simple. This is the 8:1 mux. So in this 8:1 mux, we have three select lines. We have three select lines. Okay. A, B, C. So all the three variables are present at the select lines, and the rest, the input lines are connected with 0 and 1 combination only. The combination of 0 and 1 only, 4 and 4, 8. Okay. So first is 0, second is 1, 0, 1, 0, and 1, 1, 1. So using 8:1 mux, the same function f will be implemented, which is equal to ab plus c in this way. So this is the technique of implementation of ab plus c function using 8:1 multiplexer. For 8:1 multiplexer, if your function has three variables only, then there is no scope of using any variable at input actually. All the three inputs we have to use at select lines. So this is the fundamental of this technique. Whatever the variables you have to use, first of all, on select lines, then we have to look for the input lines. If the function has m variables and your select line also m, then put all the m variables at the select lines. and input will occupy only 0 and 1s. So this is the implementation of this function using 8:1. In next video, can say, or yes. So we have to continue with this video only for implementation of this function using 2:1 MUX. The function is same. Function is same. AB plus C using 2:1 MUX. Okay. So first of all, we have to look at the 2:1 MUX. 2:1 MUX will use only one select line here and two inputs only. Two inputs only. So this is your function. Okay. I0 and I1 will be two inputs. So if I am taking A as a select line, so if I am taking A as a select line, then our table will be like this. Table will be like this. A complement and A. So this is corresponding to I0 and this is corresponding to I1. This is all about. Now we have combinations for BC. Now we have combination for BC. So it is B complement C complement, B complement C, BC complement BC. So these are the input combinations. Okay, hi. These are the input combinations. Actually, this side is input side. Select line is this. This is the select line. A complement and A are the two combinations. So first of all, fill the index values. If we fill the index values, A complement, B complement, C means 0. A complement, B complement, C means 1. A complement, B, C complement 2. Similarly, 3 and 4, 5, 6, and 7. Now the function has the main terms. Now the same steps. The function has main terms. F equal to AB plus C has the main terms 1, 3, 5, 6, and 7. So mark these all or encircle these all. 1, 3, 5, 6, and 7. So here we will see that the combination of can say B complement C plus BC. And here we have the combination of B complement C plus BC complement plus BC. Okay. If we take the C from common here, it will have C here. And if we take C common from last two terms, then it will be BC plus B complement. Sorry, B take common from last two terms. So B, so it will be B plus C. Okay. So it means we can see at I1 we have B plus C and at I0 we have C only. So also when we I was discussing it with 2:1 MUX with a standard form, we have seen that this multiplexer will contain A at the select line, and at I0 it will have C, and at I1 it has the combination of B plus C, which is nothing but an implementation of OR gate. This is the implementation of OR gate, can say B and C. Okay. So like this, we will implement this function using 2:1 MUX. So this is the basic technique of tabular form. I think this is enough for this video. I implemented this function using 8:1 MUX and 2:1 MUX with the same technique that I used for 4:1 MUX. And you can also see or can say practice this question using 2:1 MUX or 4:1 MUX by changing the select lines. So for 2:1 MUX, this is a practice. For 2:1 MUX, first select the select line B and second select the select line C. So first case, this is a select line B and second this is a select line, and practice the same question considering rest two variables as the input of the select of the 2:1 MUX. So this is your homework. And these are the basic steps of designing of multiplexer. We will see some more basic common function. We will try to implement them using the multiplexers. So this is enough for this video. Thank you.